Yes, good evening all of you. I hope you are listening my voice clearly. This is Upendra Siddhanti, Physics faculty for NEET and JEE. So, right now I am working in Spark Academy. We are discussing the concepts under in Spark Academy. So, check it, Spark Academy providing and it is giving coaching for different competitive examinations for NEET and JEE mains and advanced level program. So let us try to utilize that opportunity. So for better deals, you have to approach the Spark Academy. Contact numbers are there with you. So let us try to discuss with them, right? So today's topic is kinematics. In the kinematics, motion is straight line topic I am discussing with you. Let us go through the concept. Yes, good evening. So the basic concepts I am discussing with you. So minimum requirement need to solve all the problems in the motion in straight line concept. Definitely you should know about the calculus part in mathematics. Differentiation and integration part should be required to solve the problem. Anyway, we will discuss the required concept in motion in a straight line, right? So first one I am discussing with you. So which concepts are there? Which concepts we are discussing today? So in the part 1, distance, displacement, velocity and acceleration, equation of motion part also we are discussing today. So let us check it. What is the first point? Rest and motion. Both are relative. Yes, rest and motion both are. Yes, little bit loud. Right now you are getting more clear audible, I think. Thank you. So first we have to take a rest. An object is said to be in motion with respect to the frame of reference S1 when its location is changing with the time in same reference of S2, in same reference of S1. When you take a rest and motion both are relative terms in this case. So absolute rest and absolute motion have no meaning anywhere. Should not use absolute anywhere. But rest and motion both are relative terms each other. So next point, motion is broadly classified into 3 categories. Here, one is nothing but an So first type of motion is an rectilinear motion and or we have to call it as a translatory motion. And another one is a circular motion and rotatory motion. And another one, third type, it is oscillatory motion and vibratory motion is there. 3 types, 3 categories we were classified broadly in the motion in straight line. So first one we are considering, we are discussing right now, that is rectilinear motion, or it is also called as a one-dimensional motion, that is 1D. When we have to say there is in 1D, when a particle is moving along a straight line, then its motion is nothing but a rectilinear motion. Whenever the object is in motion, object changes its position, automatically some parameters will be generated. So parameters of rectilinear motion or translation motion, or we have to call it is an plane motion. So some parameters could be generated. What are those parameters? Let us check it once. Those parameters, so different parameters are there. Check it here. First one, time and position or location, and distance, displacement, like that. Speed or velocity, and acceleration. So these are all parameters could be existed. So first you have to see the time. So any physical quantity you have to take, that physical quantity, maybe it is a scalar quantity or it is a vector quantity. We know that one. So first parameter let us try to take time. It is a scalar quantity and its SI unit is seconds. Second point, at a particular instant of time, a physical object can be present at one location only. At any instant you have to consider a particular instant of time, a physical object can be present at only one location. Time can never decrease. That's why you could not represent in the negative format, right? So next one is second parameter is position or location. It is defined with respect to some reference point. Means you have to take an origin point of a given frame of reference. So beside picture, let us try to observe. So one particle is, I am considering the object A is the point object. At a point A, one object is located at certain point A. It is existing in the XY plane. It is existed on the XY plane. So when the object changes its position with respect to time, so when you taken, so the object is changing the position from A to B like this. So whenever at a point A it is existed, I want to refer that point from an origin point. So this is the origin point. From origin point to you have to draw one line that is nothing but a position vector. Means R1 we have to say it is called as an, here R1 bar is nothing but a position vector. Position vector. So automatically whenever object will change from A to B, then position vector will change. From origin you have to consider. So any point you have to consider on a plane, that point should be represented with respect to the origin. Then we have to call it as a position vector. Consider a particle which moves from location R1 at a time T1 to location R2 at a time T2, as shown in the figure below. So you have to take AB and another part is ACB also. So based on that one, let us try to take another parameter, third parameter, that is distance. In the given graph, position was changed. Whenever position was changed, automatically the next main parameter will be created, that is distance or displacement. So distance, major difference between the distance and displacement is, distance is, it's an actual path. Distance is nothing but it's an actual path, but displacement is nothing but a shortest path between the two positions, or shortest path between any two consecutive points. So distance, the length of the actual path traversed by the particle is termed as its distance. So distance is equal to length of the path. In the given graph, let us try to observe ACB is the distance actually. So what is the SI unit for this one? It is a meter and it should be a scalar quantity. It can never decrease with time. Distance will be increased. When you take a displacement, the change in position vector of the particle for a given time interval, it is known as the displacement of a particle. All you have to remember, it's a shortest path. There is vector quantity, so we have to represent a proper direction also. So A B bar is equal to R bar R2 bar minus R1 bar, means final position minus initial position. Displacement, it's a vector quantity. SI unit is same as distance, that is meter. It can decrease with time. The possibilities are there. That's why you will get a negative value, 0 and positive value. So next one I am taking here, for a moving particle in a given interval of time, how it is existed. Let us take it major points based on the distance and displacement of a particle. Distance can be positive, displacement can be positive, negative or 0, but distance would be always positive because it could not be decreased. So distance is always greater than or equal to magnitude of the displacement. So third point here it is, distance is always equal to the displacement only and only if the particle is moving along a straight line without any change in the direction. If it will change the direction, automatically in two physical quantities the variation will occur. So next one, average speed and average velocity. So speed is a scalar quantity and velocity is a vector quantity in this case. You know this one. So average speed and average velocity are always defined for a time interval. In between the time interval we have to calculate. First one, let us try to take average speed. So it is total distance travelled by the particle divided by time interval. That is, we have to represent mathematically delta S divided by delta T. Means change in distance divided by change in time. Then average velocity is nothing but an, instead of distance we have to use displacement here. Displacement divided by total time interval, or total displacement divided by time interval, that is delta r bar divided by, because it is a position vector representation. See, here r bar is there. So delta r bar divided by delta t, r2 bar minus r1 bar divided by t2 minus t1. That was represented in the graphical representation. In the previous slide we saw that one. So average speed is a scalar quantity. By defaultly average speed is also a scalar quantity, while average velocity is a vector quantity. Both have the same SI unit, that is in meters per second. Okay. Next 2 points let us try to observe. Star points. For a moving particle in a given interval of time, average speed can be a many valued function, but average velocity would be always a single valued function. That we have to see in the numericals. Average velocity can be positive, negative or zero, because already displacement have that particular point. Already that property is there in displacement. Displacement may be positive, negative or zero. By defaultly velocity and by defaultly average velocity also can be positive, negative or zero. But average speed would be always positive, because distance could not be decreased with respect to time. Next one, instantaneous speed and instantaneous velocity is there. How we have to represent that one instantaneous? Instantaneous speed is also defined as exactly like average speed only, but at a particular instant of time, how much speed it is going on, how much velocity it is going on. So it is equal to the ratio of the total distance and time interval, but with one qualification, that time interval is extremely instant small. Means that time interval, it is nearly equal to 0 but not equal to 0. The instantaneous speed is the speed at a particular instant of time and may have entirely different value than that of the average speed. Mathematically, how we have to represent that one? It is V is equal to limit delta S tends to 0, delta S divided by delta T is equal to ds divided by dt. Here some printing mistake is there. So this is delta T tends to 0. Here it is. We have to represent the time is nearly equal to 0. Instant time is nothing but it's in microseconds it is existed. It is nearly equal to 0 but not equal to 0. That is limit delta T tends to 0, delta S divided by delta T. So ds divided by dt we have to represent that one. So the complete limit value whatever it is there, it is represented in this format, ds divided by dt. So what is the delta S here? Delta S is a small amount of the distance covered by the particle within a small amount of the time. Within a small amount of the time. Here delta T tends to 0. That's why he has given. The ratio defining speed becomes finite and equals to the first derivative of the distance. The speed at the moment t is called the instantaneous speed at a particular time t. The same thing here it is also instantaneous velocity also There is it is based on the displacement we have to represent here. Same concept only we have to apply. So delta t, it is always tends to 0 at a particular instant of time. How much velocity it is existed, that is the limit delta t tends to 0, delta r divided by delta t. This entire content you have to represent in a form of the differentiation process, dr divided by d, means rate of change of displacement of a particle. Here rate of change of distance of a particle, right? So based on the content, so whatever we discussed about this content, based on this one we will discuss some numericals. Let us check it, the numerical here. So first numerical, in 1.0 second a particle goes from point A to point B, moving in a semicircle of radius 1.0 meter. The magnitude of the average velocity is. So when you try to take the particle A and the particle B, so here in 1.0 second a particle goes from point A to point B, it reaches here and it is reaching in a circular path. This is circular path I am considering here. So what about the radius in this case? So this is the displacement of a particle. What about the radius in this case? The radius in this case, here it is. So radius is 1.0 meters. So this is 1.0 meters. So this is 1.0, 1.0 here it is. So the magnitude of average velocity. So average velocity is equal to, what do you know about average velocity? Average velocity is equal to total displacement divided by total time taken. Now total displacement, how much it is? The total displacement is shortest distance between the 2 points. The shortest distance between the 2 points is AB, means AB divided by total time taken. That is equal to, AB is 1.0, 1.0 divided by, so 2 divided by 1 second, so that is equal to 2 meter per second. This is the basic content how you have to apply the formula for to the problem. Let us try to check it. The next question. I hope I am getting the message from Syed little louder. So from 6 to okay. So right now I hope you are listening my voice clearly. Okay. Any doubt is there? Please send me. So next example, let us try to check it. A particle moves along a semicircular path of radius capital R in time t with constant speed. For the particle, calculate 4 questions based on the given picture given. One is distance traveled, displacement, average speed, average velocity. From lower level to, I will try to go higher level problems. Let us try to check it to solve this one. So first one, a particle moving along a semicircular path. Whenever it is going semicircular path, R radius is there. Anybody send me, what about the distance travelled in this case? Anybody? Send me the message. What is the distance travelled? Distance is nothing but a length of the path, how much it is travelling. From A to B, semicircular arc it is there. That is how much? So for the solution of the first question, distance travelled, that is nothing but a path AB, that is equal to pi r. Pi into r it is. That is distance travelled. What about the displacement of a particle? The displacement of a particle, how much it is? The shortest distance between the AB points. So the radius is r, then the shortest distance AB, for the second one here it is A to O and O to B, this is AO plus OB is equal to 2R. So this is the displacement travelled by the particle, and average speed here it is there. Average speed is equal to total distance travel divided by total time taken. Total distance is pi r divided by time taken is t. I am considering here because time t with a constant speed he given. So next one, fourth question I am solving. Average velocity. So average velocity is equal to total displacement divided by time taken. This is 2r divided by t. Right? Very small content, very small problem. Let us try to check it. Next one. Yes, thank you Fariduddin. You send the solution to me. And next example, let us try to check it. A body travels the first half of the total distance with velocity v1 and the second half with velocity v2. Calculate the average velocity. From here, you have to try to solve yourself. I will also solve, listen, but you have to try yourself also. Okay. So next, a body travels the first half of the total distance with a velocity v1 and second half of the distance with velocity v2. Let us consider I am taking from A to B is the complete distance travelled by the particle. The first half of the distance I am taking here with a speed of v1. So from A to C, x distance it was travelled with a speed of v1, and remaining x distance it is travelled with a speed of v2. So when I consider like this, this is completely x distance, it is x by 2, like that. Let us try to consider. So this is x by 2 distance, and this is C to B x by 2 distance. How we have to solve the problem? What you know about the content? So the total distance travelled by the particle, or let us consider total distance covered by the particle is equal to x. Then now total time taken, how much? Total time taken, because I want to find out average velocity. Average velocity is equal to total displacement divided by total time taken. Total distance or total displacement, it is in a straight line, so I am considering distance or displacement anything. So x it is, so r divided by t. Okay, so total distance is equal to s. What about the total time? Time is not there here, but you know about the speeds of the particle. Then now total time is equal to, let us try to take an in terms of the x and v. First half of the distance it was covered, so x by 2 distance it was covered with certain speed, that is v1. So what you know about the basic formula? So speed is equal to distance divided by time taken. So that is s divided by time taken, right? So in terms of t, in terms of x and v, you have to consider that is x divided by 2v1. X divided by 2v1. Let us try to take on like that. So in terms of first A to C, it was travelled in a time in terms of x and v, x divided by 2v1 plus, and second part C to B, it was travelled x divided by 2v2. So now let us try to calculate average velocity. V average is equal to total distance is x divided by total time taken. Here it is x, you have to take in common, then you will get x by 2, you have to take in common. This is 1 divided by v1 plus 1 divided by v2. In x you will get cancelled. Then let us try to calculate this one. You will get, so let us try to calculate this one. I will try to calculate here. So okay, x will get cancelled. Then this 2 you have to take in the numerator. Then average velocity is equal to 2 divided by denominator you have to take LCM, that is V1 and V2, then you will get this is V1 plus V2. This one you have to take a numerator, then finally you will get average velocity is equal to 2 V1 V2 divided by V1 plus V2. So this is the solution for that one. I hope all of you are following. Right. Next question, let us try to check it. This is example 4. Velocity time equation of a particle moving in a straight line. The given velocity equation, that is V is equal to, in terms of means relation, it will show to you velocity and time relation. That is V is equal to 10 plus 2t plus 3t square. So based on this equation, you have to try to find displacement of particle from the origin of time t, that is equal to 1 second. If it is given that displacement is 20 meters at the time t is equal to 0. And the second question, based on the given data, he asked acceleration time equation is what? This is what he given actually. Velocity time equation he given. You have to find out acceleration to time equation you want to find. So let us try to solve the first question. So based on the given content, first what he given? He given V is equal to 10 plus 2t plus 3t square he given. You want to find the displacement of a particle. To find the displacement of a particle from this one, what you want to write behind the images. Okay. Right. I will try to avoid that one. Let us try to check it. I could not write on the images, no problem at all. So, I want to try to find out in the first case displacement of a particle. To find the displacement of a particle, so velocity is equal to rate of change of displacement. How I want to represent that one? That is ds divided by dt, right? So this is ds divided by dt. What I want to find? I want to find the total displacement of a particle. So total displacement of a particle I want to find. That's why I want to take ds is equal to, just transpose this one, v into dt. So velocity equation is there with you. Then try to substitute that one. This is small amount of the displacement what you will get here, but you want to try to find the total displacement of a particle here. Total displacement of a particle, see, displacement of a particle from origin of time t is equal to 1 second. At the time of t is equal to 1 second origin, if it is given that displacement is 20 meters at the time of t is equal to 0, means how I want to consider this integration. When I do the integration process, so when I do the integration process, I will get the entire value of the displacement. When I try to displacement of a particle, so integrate this entire equation. What about the limits in this case? The limits in this case is lower limit is 20 and upper limit is yes, I want to consider here based on the given content. So from here, right side, I want to try to do the integration from 0 to t. So at the time of t is equal to 0, it is a lower limit. The displacement is 20 meter. That's why I was taken here 20 at a lower limit, and displacement of a particle from the origin. That's why I was considered here yes, in this case at the time of t is equal to 1 second. So when you try to substitute this one, integration of ds is nothing but an yes. I hope you know, all of you, how to solve the integration process. So 20 to s, that is equal to integration of v into dt. Integration of v is v equation 10 plus 2t plus 3t square into dt, right? So when you try to integrate this one, what you will get? 10 into dt plus integration of 2t into dt plus integration of 3t square into dt. When you try to solve this one, each and every term separately, 10 is a constant in this, 2 is a constant in this, 3 is a constant in this, taken outside, then integration of dt is nothing but an what? It's a t, right? So integration of t into dt, what you will get? This is t power 1 plus 1 by 1 plus 1, that is t power 2 divided by 2. Which formula I will use in this case? Integration of x power n into, I will write this one. So integration of x power n into dx is equal to x power n plus 1 divided by n plus 1 formula I will use to solve entire equation in this case. So when I try to solve entire equation, what I will get the final equation here. So when you try to solve this one, you will get the entire equation, that is 10 into t plus 2 into t square divided by 2 plus 3 is there, 3 into t cube divided by 3, you will get here. It is from 0 to t. Then 3 and 3 will get cancelled, 2 and 2 will get cancelled here. So when you try to take and frame the equation, you have to substitute upper limit and lower limit in this case. Upper limit minus lower limit, that is s minus 20 is equal to, finally you will get 10t plus t square plus t cube. It is from 0 to t. So upper limit minus lower limit, when you try to substitute the 0, you will get the same equation in this case. So let us try to solve this one. T is nothing but an what? At the time of t is equal to 1 second, he asked it to you. When you try to substitute, instead of t, you have to substitute in the all t's, you have to substitute value 1, what you will get. So s minus 20 is equal to 10 plus 1 plus 1, that is you will get 12, you will get that. This is 12. So solve this one, finally you will get s is equal to 32 meter, you will get here. This is 32 meter. So like this you have to solve the first problem. So let us try to check it. What about the acceleration and time equation? If you want to copy this one. I hope all of you are following. So let us try to take next question. So question B I am trying to solve. So to get the acceleration from the given equation of velocity v, then I want to take an acceleration a is equal to, that is rate of change of velocity. So rate of change of velocity d by dt of entire equation 10 plus 2t plus 3t square, right? So when you try to differentiate that one, you will get, differentiate the constant, you will get the 0 value, and differentiate 2 into dt divided by t, what you will get here, this is integrate d by dt of 10, anyway constant, you will get 0 plus 2 into dt by dt plus 3 into d by dt of t square. So which formula I want to use here? D by dx of x power n into x power n minus 1 you will get here. So finally you will get acceleration equation is So here you will cancel this one. This is 2 plus 3 to the 6, 6t you will get here. This is the acceleration equation. Right? Again, next question. If displacement is depend on time such that x is equal to 2t minus 2, then find out average speed up to 4 seconds how much it is existed. Average speed 4 seconds how much it is existed. So to solve this one, what about the given equation first of all? Let us try to check it. Solution. So what about the given equation? Given is x is equal to 2t minus 2 it is. So find out average speed up to 4 seconds he is asking. So up to 4 seconds you have to try to take at the time of t is equal to 0. What about the displacement of a particle? What about the displacement of a particle? So 2t minus t. When you take on 0, you will get minus 2 is the value. So same at the time of t is equal to, up to 4 seconds I want to find, t is equal to 1, then x is equal to 0 meters you will get here. X is equal to 0 meter. Same at the time of t is equal to 4 seconds. When you try to substitute 2 here, 2 to the 4, 4 minus 2, 2 you will get. At the time of t is equal to 4 seconds, I will get, this is up to 4 seconds, no? 1 to 4 directly I am taking here. This is 6 meters you will get here. 2 4s are 8, 8 minus 2, 6 meters. From 0 to 0 meter to 6 meters. And all the values let us try to add. You will get the total distance. So total distance is equal to modulus of minus 2, because here it is negative is there. Let us try to take a mod. You will get the positive plus 6 meter. So you will get 6 plus 2, you will get 8 meter here. Right? So now average speed you want to find. So average speed is equal to total distance traveled divided by total time taken, how much it is, 4 seconds of time, that is equal to 2 meter per second. Yes, next question let us try to take. The next question, next example is, if velocity is dependent on time such that v is equal to 4 minus 2t, find out distance travelled by the particle from 1 to 3 seconds. See, this is one different type of question here it is, right? Like these questions you will get, you have to follow one procedure. So let us try to find out. So what he is asking, velocity is depend on time, that is he given equation anyway, that is v is equal to 4 minus 2t he given. Okay, Find out distance travelled by the particle from 1 to 3 seconds. Means 1 second, first second to second second, and second second to third second. How much distance it is travelled completely you want to find. So in between 1 to 3, second second is there. What happened at that situation we don't know. Let us try to check it at that situation. What about the velocity of a particle? So for example, here at the time of t is equal to, at the time of t is equal to 2 seconds, the velocity of a particle v is equal to 4 minus 2 into 2. Means velocity is 0. Means at the time of t is equal to 2 seconds, means in the second second the object is at rest position at that time. So for a given equation, first you have to check this one. Afterwards, for a distance you have to follow, for a distance you have to follow dx divided by dt is equal to, because velocity is nothing but a rate of change of displacement, is equal to 4 minus 2t he given. Now you will get here dx is equal to, so dx is equal to 4 minus 2t into dt you will get here. To find the complete value of this one, so let us try to integrate this one. So what you will get? So dx is equal to modulus of integration of 4 minus 2t into dt. It is from 1 to 2 plus integration of modulus of integration of 4 minus 2t into dt. It is from 2 to 3. So like this you have to take. You will get the answer here. Dx is equal to, so this is entire part you will get 1. When you try to solve this one, integration 4t you will get minus 2 t square divided by 2 minus t square you will get here. When you try to substitute upper interval minus lower interval in this equation, you will get the x is equal to 1 plus 1. So totally, sorry, here I want to do integration process. So you will get x is equal to, means total distance traveled, it is x is equal to, from 1 to 3 seconds you will get how much distance it was traveled, means 1 plus 1 you will get entirely 2 meters it was traveled. 2 meters it was traveled. Like this you have to follow whenever he asks the distance traveled by the particle from 1 to 3 seconds of time. Means in between the second, the velocity of the object is 0 or not, let us check it. Afterwards you have to follow. Right. Let us try to check it. The next question. If velocity is given by following function, that is v is equal to x square, then find out the relation between x and t. Assume that x is equal to 1 meter to 1 meter at the time of t is equal to 0 he is asking. So the velocity is given by the following function he given. So velocity is equal to x square. So given content here it is that v is equal to x square. Relation between x and t you want to find. Means you know this one, velocity is equal to rate of change of displacement of a particle. Right. Now let us try to take dx divided by dt is equal to, what about v? V is nothing but a x square. So let us try to transpose that x square like this. Let us try to take dx divided by x square is equal to dt. Why I was taken like this? I want to try to find out the relation between x and t. So complete x terms I was taken left side and differentiation of t there it is there. So let us try to integrate both sides with respect to. So integrate both sides, then integration of dx divided by x square, it is from 1 meter 1 to x, here it is, means at the time of t is equal to 0, it is assumed that x is equal to 1 meter. That's why I was taken 1. After some time, how much distance it is traveled, we don't know. That's why I was taken x here. And integration of dt, it is from 0 to t seconds. How much time it was traveled, I don't know. That's why I was taken t. See, it is reverse, it is there. So from 1 to x, 0 to t. So you have to substitute that one. Integration of 1 by x square into dx is minus 1 by x, here you will get. That is from 1 to x, that is equal to integration of dt is nothing but an t, it is from 0 to t. When you substitute the upper interval and minus lower interval, what you will get? So minus 1 by x plus 1 minus 1 by x plus 1 is equal to t, you will get. So when you try to solve this equation, finally you will get x is equal to, so finally you will get x is equal to 1 by 1 minus t, you will get. Just transpose this, I want to find out x, just take an LCM here, 1 plus x divided by x, here will get, otherwise sorry sir, will there be revision session every day? Yes, I will discuss with you, no issues at all. Yes, I will discuss with you. Just I want to complete this one. You have to try to solve that one. You will get x is equal to 1 divided by 1 minus t, you will get here. Okay. So this is the content. So these are the examples. Today I was discussed with you based on the entire concept. Anyway, before finishing the today's class, I will discuss with you another concept. It is average and instantaneous acceleration. Average and instantaneous acceleration, when the velocity of a moving object or particle changes with time, we can say that it is accelerated. The object is accelerated. So what about the average acceleration? Always remember, average velocity is equal to change in displacement by time interval. Like the average acceleration also. So change in velocity divided by time taken, time interval. Change in time. That change in time or change in any parameter, physical quantity, you have to represent like this in deltas. So that is delta V divided by delta T. Means delta V is nothing but what? Delta V is equal to, that is final velocity minus initial velocity. So delta T is nothing but an T2 minus T1, right? So that's he represented like this. This is average acceleration you will get. What about the instantaneous? Whenever he will ask about the instantaneous, that should be existing in limits. That average acceleration you have to represent in terms of the limits. Means at the time, whatever you have to consider, the time taken, at the time taken t is equal to 0. At the time of t is equal to 0, then what about the acceleration of the particle? That's why I am considering here limit delta t tends to 0, average acceleration, that is delta v divided by delta t, that is equal to, you will get dv divided by dt. This dv bar divided by dt, you will get rate of change of velocity. That is nothing but an instantaneous acceleration. So instantaneous acceleration, that's why we have to represent directly, that is dv bar divided by dt. Why you have to represent like this, dv bar divided by dt? So before that complete change in velocity divided by change in time, it is existing within limits. We were consider that value in limits at the time of the time it is tends to 0, means it is nearly equal to 0 but not equal to 0. Acceleration, here it is a vector quantity whose direction is same as that of the change in velocity vector. Its SI unit is meters per second square, right? And the next point beside next box, let us try to check. When direction of acceleration is and velocity are opposite to each other, so whenever it is there like this, it is retardation. Both acceleration direction and velocity direction same it is there, automatically that is nothing but an acceleration, means speed will be increased gradually. So whenever both acceleration and velocity are opposite to each other, then by defaultly acceleration will be decreased, speed will be decreased. That is nothing but a retardation. We have to call it as a retardation, or we have to also call it as a deceleration process, right? So that is also you have to represent it same format. And another point he given, so chain link is, so A is equal to dV divided by dt. This dV is nothing but an V is nothing but an what? Rate of change of displacement of a particle. This is you have to write in terms of the R also, d square R bar divided by dt square. So here you have to write down V bar into dV divided by dr. This we will discuss at the time of problem, no issues at all. Next one, last final content, constant acceleration format. Deduce the following equation for uniformly accelerated motion by using the integration technique process. So accelerated motion equations, 4 accelerated motion equations are there, but before A, B, C equations already you learnt in the previous classes, that is in 9th class it is existed for your CBSE. That is V is equal to U plus AT, S is equal to UT plus half AT square, and C, so third equation is V square minus U square is equal to 2AS. And the fourth one is a new equation, new accelerated motion equation, constant accelerated motion equation it is. That is how to find the nth displacement of a particle. How to find the nth displacement of a particle. The second equation, this is a displacement covered by the particle in certain time interval. But what about the displacement covered by the particle in any 1 second? In 1 second, means it is first second or second second or 100th second. Any 1 second you have to consider. In 1 second of time, how much it is covered, that's equation we will find U plus A by 2 into 2n minus 1. This is the new equation he given in class 11, right? So previously you learnt about those equations already. So those equations you have to check it in the integration process, it is there. Anyway, I will discuss with you in the next class. 10 to 15 minutes I will discuss with you. Afterwards, based on that one, we will go through some numericals and we will discuss about the graphical representations also, right? I hope all of you are following and you are understanding the content and numericals. Let us try to check it. So what about the chart? Somebody sent to me, Syed Aisha sir, can't see what you have written behind the images. Definitely I will rectify because I don't know that one. So when I saw your message, actually I didn't write in the previous slides. So behind the screen I am not writing. Somewhere initially I wrote like that, I think. I am sorry. And the next one, extraction X sir. I am not understanding what you are messaging. So somebody sent to me. Okay, I did not understand your message. Sir, will there be revision sessions every day? Actually, I don't know that one. I don't know that one, but let us try to discuss with management of the Spark Academy. So I don't know, but I will ask with the management. So afterwards I will say to you information. And next one, I am Ekchit sir. Hi Ekchit. And any doubts are there, send me. Watching your chart actually. So any doubts are there, send me. No issues at all. Yes, no doubts. Thank you. Thank you. So in this seventh question, sixth question, little bit of different questions at the time of integration, how you have to take on the lower intervals and upper intervals. Please kindly follow that one. Here I was taken, see the example 6 and example 7. Both are different because here we are doing what we will do. Generally, integration process only we will do. But how we will take the lower and upper intervals, let us try to check that one. Those type of problems you will get because it is a very easy chapter, first chapter. No need to worry. Thank you very much. Thanks for your cooperation. Take care all of you. Don't go outside. Practice well. In the next class we will meet and I will try to complete the concept in the next class. So motion in a straight line concept. Thank you very much. Thank you. Very good evening all of you. Bye.